Hello everyone. In this video I will be working on this audio amplifier, but first I will start with a short presentation. This is a Sony amplifier. The model is F445R. This amplifier is part of the Demo series. These amplifiers belong to a limited lineup and are known for delivering a different sound character compared to more common design. It has a premium appearance with a metal black top cover and a glossy black aluminum front panel. On the front panel we have a power button with standby and short circuit protection. The tone control selection is quite simple, featuring only two adjustments, bass and treble. There is also a balance control, and the tone correction can be completely bypassed from here. The amplifier is equipped with a loudness function. This button is used either for the recording function or for connecting an external equalizer. It also includes the on function, which stands for automatic standby. When the amplifier no longer receives an audio signal from the source, it automatically enters standby mode. Here we have the input selector, and next to it the volume control. On the front panel there is a 6.3mm headphone jack located below the ear receive, and next to it the speaker output selector from A and B channels. On the rear panel the power cable is permanently attached, along with 3 IC outlets from additional devices. On the rear panel, this is where the speakers are connected, and it's very important to pay attention to the speaker's impedance and follow the manufacturing specifications. Here we have the RCA inputs, which allow you to connect the sources such as a laptop or a computer using an appropriate cable for the phono input. Please note that it is designed only for low-level signal sources such as turntable. In my opinion, this amplifier is definitely worth preserving, but after many years for use, it requires proper diagnostics, as it shows several issues that I will demonstrate it shortly. Now I'll power it on and check whether the controls, selector and buttons are functioning correctly while playing a music track. Now I'm going to plug in. I'm going to start it now. So far it's okay. Now I'm going to connect the speaker. The selection is set to A. I will test the amplifier on this speaker. Now I'm going to connect the audio signal, and now I'm going to check all this function. I noticed that an anomaly occurs when I turn the volume up with the correction activated. Look at the speaker. Has now entire protection mode. If I restart it, it comes back. Look at that. In protection mode. When it's in direct mode, then it's fine. I'll open the top cover to investigate. Now I'm going to take the top cover off. Look at that. This appears to be a rather usually volume control design. On the front board we can see that looks like the digital control section. The power supply seems quite small and very simple, using only a single bipolar voltage rail. This section here is the power supply for the standby and protection functions. The capacitors are of high quality and do not appear to be leaking onto the board. The transistors are original MOSFET devices, and it does look like anyone has worked on this unit before. On the input board we have the integrated circuit responsible for input selection, as well as the phono amplifier stage. All components appear to be original, according to the service manual. Judging by its condition, it looks like the unit has been exposed to moisture. There is dust and visible signs of corrosion. Take a look at how it looks on the underside as well. I will clean it first, then power it on and perform some measurements. Now I'm going to take apart the amplifier board. This is what the amplifier board looks like on the back. Look at how rusty it is. I'm going to remove the cover from under the amplifier. Take a look. I'm going to use these tools to clean the rust. Now the motherboard is clean. I noticed that it has some unsoldered pin on the board, and I will resoldering all affected pins. Now I finished resoldering all the loose connections. Now that I've installed the main board back into the amplifier, I'm going to power it on and start the measurements. I'm going to plug in. I'm going to power. First, I measure the bias current and adjust it to 20 mV DC, exactly as specified in the service manual. In the first time, I will connect the multimeter to the diagnostic port. I will use a screwdriver for adjustment. Look at that. It's good. Now I will move on to the next channel. I connected the multimeter to this other channel and look how much bias it has. Now I'm going to adjust this channel as well. Unfortunately, I was not able to adjust the bias due to a fault in the circuit. After troubleshooting, I found several resistors that have drifted significantly from their original value and need to be replaced. I replaced the faulty resistors on the other channel as well and recalibrated the bias once again. Now the LEDs are much brighter, which clearly shows that the amplifier has come back to life. Next, I'm going to measure the supply voltage on the preamplifier circuit. Look at that, it's fine. Next, as you can see on the minus 15 volts rail, this is only about 300 millivolts, and I believe this is the reason why when activating the tone control, the amplifier was producing low popping noise in the speakers and entering protection mode. When activating the tone control, the amplifier was producing loud popping noise in the speakers and entering protection mode. After a few more measurements, I found this Zener diode shorted. I'm going to replace it with a new one. You can now see the new Zener diode installed. And as you can see, the voltage has returned to its normal value. Now I'm going to check the tone control functions again to see if everything has returned to normal. It's good. It's fine. It looks like everything is working as it should. I'm going to remove the front panel to make sure everything is in good condition. This is the control panel. As you can see, this is how all the components looks and everything appears to be fine. I'll clean the control using contact cleaner and then reassembling everything. Now I move on to the audio test to check if there are any remaining issues with the controls. Now I've connected the amplifier to the speakers and to this laptop to run a music test. As I can hear, it seems to sound good without any issues. Now I'm going to move on to the oscilloscope test. First, I'll measure the DC offset with no load and leave the multimeter connected to observe how much the offset change over time. After further checks, the sine wave on the oscilloscope looks clean and the offset is within normal limits. Now I'm going to perform a square wave response test. However, it seems that the frequency response is not as fast as I initially expected. I perform the same test on the other channel. It behaves in the same way, which means everything is working correctly, and this is how the amplifier was designed. If I replace these two transistors in the VAS stage with other that have lower parasitic capacitance, the amplifier will have a much faster response time. And that's about it for this amplifier. I'm glad it didn't have any serious issues. That's all for this amplifier repair. If you have any questions, feel free to leave them in the comments below. Don't forget to like, subscribe and support this channel. If you want to see more electronics and audio repair content, thanks for watching.